The 7600HT Yellowfin plate boat stands out in the realm of offshore fishing vessels due to its robust construction and thoughtful design. Engineered by Quintrex, this boat is tailored for those who seek serious offshore fishing adventures, offering durability and performance that meet the highest standards. Structural integrity: the 7600HT Yellowfin is built with precision and strength at its core. The boat features a beam of 2.40 meters, providing a stable and spacious platform for fishing activities. The construction involves using 6 mm thick bottom sheets and 4 mm thick topside sheets, ensuring the vessel can withstand the harshest marine environments. The hull is reinforced with an internal marine core rib structure, which adds an additional layer of durability and rigidity to the boat. This construction method not only enhances the overall strength of the vessel, but also contributes to a smoother ride in choppy waters. Extensive welding process: the construction of each 7600HT Yellowfin model includes over 80 hours of meticulous welding. This extensive welding process is critical for ensuring the boat's structural integrity and longevity. Specifically, the weld build time amounts to 71 hours, during which skilled craftsmen work to ensure every joint and seam is perfectly fused. This dedication to welding precision guarantees that the boat can handle the stress and strains of offshore fishing without compromising safety or performance. Designed for offshore fishing, the 7600HT Yellowfin is designed with serious offshore fishermen in mind. Its robust build and design features cater to the needs of anglers who venture into deep and often unpredictable waters. The heavy-duty construction materials and processes used ensure that the boat can handle rough seas, providing a reliable and safe platform for fishing. The 2.40-meter beam adds to the vessel's stability, allowing anglers to move around the boat comfortably and securely, even when the sea conditions are less than ideal. Australian craftsmanship proudly built in Australia, the 7600HT Yellowfin reflects the high standards of Australian boat manufacturing. The use of high-quality materials and advanced construction techniques showcases the country's expertise in producing vessels capable of tackling demanding offshore conditions. Australian craftsmanship is synonymous with durability and performance, and the 7600HT Yellowfin is a testament to this reputation. A formidable vessel designed for the avid offshore fisherman. Its construction is marked by the use of thick, durable materials and an extensive welding process that ensures unmatched strength and reliability. The internal marine core rib structure further fortifies the hull, making it well-suited for challenging marine environments. Ulsan Shipyard, one of the world's largest shipyards operated by Hyundai Heavy Industries, HHI, in South Korea, follows a process for shipbuilding that ensures efficiency and precision. The process begins with the installation of the engine, the ship's heart. The main engine is carefully placed onto the engine bed within the ship's hull. This step is critical as it involves aligning the engine precisely to ensure optimal performance and minimize vibrations during operation. Advanced machinery and techniques are used to secure the engine firmly. Floating at Ulsan Shipyard involves a process where the partially constructed ship transitions from a dry dock to a floating dock. Initially, the dry dock, a large basin where the ship is built, is flooded with water. This allows the vessel to float for the first time. Tugboats and specialized equipment then guide the ship from the dry dock to a floating dock or quay. This stage requires careful coordination to ensure the ship remains balanced and secure, preventing any structural stress or damage. Floating is crucial as it signifies the ship's readiness for further assembly and installation phases. Following floating, the engine casing is installed. This structure houses the engine and related machinery, providing protection and accessibility for maintenance. The engine casing is constructed and integrated with precision to ensure all components are properly shielded and ventilated. Deckhouse installation at Ulsan Shipyard involves placing the prefabricated structure onto the ship's hull using heavy-duty cranes. The deckhouse, which includes the bridge, command center, and living quarters, is aligned and secured to ensure it integrates seamlessly with the hull. This step is crucial for maintaining the ship's structural integrity and functionality. After the deckhouse is in place, the ship is prepared for launching. This involves moving the ship from the construction site to the water. In Ulsan Shipyard, this can be done via a side launching method or by using a floating dock. The ship is slowly and safely released into the water, marking a significant milestone in its construction. The final step is the sea trial, where the ship is tested in real sea conditions. During the sea trial, various performance parameters, including engine performance, speed, maneuverability, and safety systems, are rigorously tested. This step ensures that the ship meets all regulatory standards and performs as expected before it is delivered to the customer. In just 6 months, the construction of the Inchcape 23, a stunning 23-meter boat crafted from magnesium alloy, was completed. This impressive feat of engineering and craftsmanship involved a meticulous process that began with the selection of materials known for their strength and lightweight. Magnesium alloy, chosen for its durability and resistance to corrosion, was expertly worked into the boat's structure, ensuring longevity and performance on the water. The build process, which took a total of 7 months, involved several stages. Initially, the boat's frame and hull were carefully constructed to provide a solid foundation. Skilled technicians then fitted and reinforced the structure with magnesium alloy panels, followed by precise assembly of the interior and exterior components. Attention to detail was paramount throughout, as each part was meticulously crafted to meet high standards of quality and functionality. Once completed, the Inchcape 23 embarked on her maiden voyage, navigating the scenic Exeter Canal in Devon. This initial journey allowed the team to test and fine-tune the boat's performance in real-world conditions. Following this, the boat was transported to Devonport for its final relocation. To complement the build documentation, 7 additional videos offer 360-degree walkthroughs of the boat's interior, providing an immersive view of the vessel's luxurious and functional design features. The 15,000 TEU LNG vessel represents a significant advancement in maritime technology and environmental sustainability. TEU, or 20-foot equivalent unit, measures cargo capacity. And with a capacity of 15,000 TEU, this vessel is among the largest in its class, specifically designed for container shipping. Utilizing liquefied natural gas, LNG, as its primary fuel, this vessel stands at the forefront of the industry's efforts to reduce carbon emissions and promote cleaner energy sources. LNG is known for its lower carbon footprint compared to traditional marine fuels, such as heavy fuel oil or marine diesel oil. It significantly reduces emissions of sulfur oxides, SOx, nitrogen oxides, NOx, and particulate matter, contributing to better air quality and compliance with stringent international regulations like the International Maritime Organization's IMO 2020 sulfur cap. Additionally, LNG engines are quieter and produce less vibration, enhancing crew comfort and reducing marine noise pollution. The adoption of LNG for such a large-scale vessel underscores a commitment to sustainability and innovation. The vessel's design integrates advanced technologies, including state-of-the-art LNG storage and fuel supply systems, efficient dual-fuel engines, and optimized hull designs for enhanced fuel efficiency. This combination of features ensures not only reduced greenhouse gas emissions, but also improved operational efficiency and cost-effectiveness. By offering the cleanest and greenest alternative to traditional ship propulsion, the 15,000 TEU LNG vessel represents a crucial step forward in the maritime industry's journey toward decarbonization. It serves as a model for future vessels, demonstrating that it is possible to achieve significant environmental benefits without compromising on performance or capacity. As the industry continues to embrace greener technologies, such vessels will play a pivotal role in shaping a more sustainable future for global shipping.
Building a cold-molded 22 feet center console boat involves a meticulous manufacturing process that combines traditional craftsmanship with modern techniques. Cold molding is a method of constructing wooden boats using multiple layers of thin veneers, creating a strong and lightweight hull. The process begins with designing the boat, taking into consideration factors such as size, weight, stability, and performance. Once the design is finalized, the next step is lofting, where the boat's lines are drawn full scale on a lofting floor or using computer-aided design CAD software. The keel plays a crucial role in the structural integrity and stability of a boat. It serves as the backbone running longitudinally along the center line of the hull. Typically, the keel is constructed from a solid timber piece that provides strength and rigidity. The frames, also referred to as ribs, are then built and attached to the keel, forming the skeletal structure of the hull. These frames are usually made from steam-bent or laminated wooden strips. Steam bending involves heating the wooden strips to make them pliable and then shaping them to fit the contours of the hull. Alternatively, laminated wooden strips can be used for the frames. In this method, thin strips of wood are glued together under pressure to create a strong and flexible frame that conforms to the desired shape. Laminated frames offer excellent strength and resistance to warping. The frames are strategically spaced along the keel to provide support and maintain the desired shape of the hull. They help distribute the loads and stresses evenly throughout the structure, enhancing the overall strength and durability of the boat. The attachment of frames to the keel is typically done using epoxy resin and mechanical fasteners such as screws or nails. Cold molding is a method of boat construction that utilizes multiple layers of thin wooden veneers to create a strong and lightweight hull. The veneers used in cold molding are typically made from marine-grade plywood or other suitable materials such as mahogany or cedar. Each veneer layer is carefully cut to shape and coated with epoxy resin. The epoxy resin serves as an adhesive, bonding the veneers together and creating a solid composite structure. The veneers are then laid diagonally or at angles to each other during the lamination process. To further enhance the structural integrity, the veneers are fastened together using a combination of epoxy resin and mechanical fasteners like screws or nails. The epoxy resin ensures a strong bond between the veneer layers, while the mechanical fasteners provide additional reinforcement. The use of epoxy resin in cold molding not only acts as an adhesive, but also serves as a protective barrier against water intrusion. By employing multiple layers of veneers, coated with epoxy resin and fastened together, cold molding creates a robust and lightweight hull structure. After the planking process, the hull undergoes fairing and sanding to achieve a smooth and uniform surface. Skilled craftsmen utilize a range of tools and techniques to meticulously remove any imperfections, bumps, or irregularities in the wood. This process ensures that the hull has a seamless and symmetrical shape. Tools such as hand planes, sanders, and fairing boards are used to carefully sculpt and shape the hull. The craftsmen work diligently to achieve a flawless surface, paying close attention to details and continuously checking the hull's fairness and symmetry throughout the process. The result is a hull with a sleek and polished appearance, ready for the next stages of construction. To bolster the strength and durability of the hull in cold molded boat construction, a layer of fiberglass cloth is applied to the exterior surface of the planking. Fiberglass cloth, known for its high tensile strength, is placed over the hull and saturated with epoxy resin. The epoxy resin acts as both an adhesive and a protective coating. As it cures, it forms a chemical bond with the wood, creating a strong connection and reinforcing the structure. Multiple layers of fiberglass cloth may be applied, with each layer meticulously wetted out with epoxy resin. The fiberglass cloth provides a protective barrier against water intrusion, shielding the underlying wood from moisture and preventing rot or decay. It also adds impact resistance and helps distribute stresses evenly across the hull. By incorporating fiberglass, cloth, and epoxy resin, the hull gains added structural integrity, increased resistance to impacts and abrasion, and improved longevity, making it well suited for demanding marine environments. The first step in building a hull mold is to construct the plug frame. This frame serves as the skeleton onto which the hull shape will be formed. It is typically made of wood or metal and is built according to the specifications provided by the naval architect or boat designer. Once the plug frame is securely in place, the process of attaching planks begins. These planks serve as the primary structure and form for the mold. Typically made of wood, they are carefully shaped and fitted to accurately represent the desired hull shape. The planks are meticulously cut and shaped according to the design specifications, taking into account the curvature and contours of the hull. Skilled craftsmen use various tools such as saws, planes, and chisels to achieve the precise shapes required. Each plank is then securely fastened to the plug frame using screws, nails, or adhesive, ensuring a strong and rigid structure. Great care is taken to align the planks correctly and maintain the intended hull shape throughout the process. As the planks are attached, they gradually form the hull's framework, providing the necessary structure for the subsequent steps. The accuracy and precision of this plank installation are crucial, as any deviations or errors can impact the final shape and quality of the mold. After the planking is complete, the next crucial step in building a hull mold is sanding the entire surface of the plug. This meticulous process is essential to achieve a smooth and uniform finish, eliminating any imperfections or irregularities that could transfer to the final mold. The sanding process begins with coarse grit sandpaper to remove any rough spots, protrusions, or high points on the surface. This initial sanding helps to level out the planks and create a more even base. As the sanding progresses, finer grit sandpaper is used to smooth out the surface further. This step helps to refine the contours and curves of the hull, creating a sleek and precise shape. The sanding is typically done by hand or using sanding blocks to maintain control and precision. Once the surface of the plug has been filled and sanded to perfection, the next step in building a hull mold involves applying a primer. The primer serves as a base coat, providing several important benefits for the mold construction process. The primer is typically sprayed onto the plug surface using specialized equipment. It is a specially formulated coating designed to enhance adhesion and promote the bonding of subsequent layers to the plug. The primer acts as a bonding agent, ensuring a strong connection between the plug and the layers that will be added. The application of primer has several key advantages. Firstly, it helps to seal the surface of the plug, preventing moisture penetration and potential damage to the mold. Secondly, the primer enhances the surface's texture, providing a better grip for subsequent layers of materials, such as fiberglass or gel coat. This improved adhesion helps to create a more durable and reliable mold. Additionally, the primer helps to create a uniform and consistent surface, ensuring that the subsequent layers are applied smoothly and evenly. It also helps to enhance the appearance of the mold, creating a clean and professional finish. The choice of primer depends on the specific requirements of the mold construction process and the materials being used. The primer is typically selected to be compatible with the subsequent layers and the overall construction process. Once the fiberglass layers are in place, a gel coat layer is applied to the mold. Gel coat is a specialized resin that provides a smooth and glossy finish to the mold surface. It also acts as a protective barrier against the elements. Work begins. Once the fiberglass layers are in place, A gel coat layer is applied to the mold. Gel coat is a specialized resin that provides a smooth and glossy finish to the mold surface. It also acts as a protective barrier against the elements. The assembly process of the Iona, P&O Cruises' new flagship indeed involved several stages and collaborations between different shipyards. Let's delve into the details of this complex process. The construction of a large cruise ship like the Iona is a highly coordinated effort that requires the expertise of multiple shipyards specializing in different areas. Each shipyard plays a crucial role in building specific sections or components of the vessel, which are later integrated at the main shipyard. VNBN-MIC-NH. Once the major sections are built, they are transported to the main shipyard for final assembly. This integration phase is where the various sections are carefully joined together to form a cohesive and functional vessel. Skilled workers at the main shipyard oversee this process, ensuring precise alignment, welding, and fitting of the sections. At the Neptune Werft, the engine room module was constructed. This module housed the modern power plant that would supply the entire ship with energy, including hotel operations. The power plant was designed to be efficient and environmentally friendly, aligning with the ship's focus on sustainability. Neptune Werft's expertise in building complex engine room modules ensured that this critical component of the ship was constructed to the highest standards. The installation of propellers for a cruise ship like the Iona is a crucial step in the assembly process, as they are responsible for propelling the vessel through the water. Before the installation process begins, the propellers for the Iona are designed and manufactured to meet the specific requirements of the ship. Propellers are typically custom designed for each vessel, taking into account factors such as size, power, and efficiency. Prior to the installation, the shipyard prepares the Iona for the propeller installation process. This involves ensuring that the hull area where the propellers will be mounted is clean and free from any obstructions. The propeller shafts, which transmit the power from the ship's engines to the propellers, are carefully installed in the designated positions within the hull. These shafts are securely fastened and aligned to ensure smooth rotation and minimize vibrations during operation. Once the propeller shafts are in place, the propellers themselves are mounted onto the shafts. For several years, 3X Engineering has been at the forefront of developing advanced composite materials suitable for underwater applications. The need for efficient and reliable repair methods for subsea pipes led to the development of BobbyWrap. This cutting-edge machine allows divers to apply the reinforcement for subsea composite wrap accurately and effectively. The primary function of the BobbyWrap is to ensure optimal application of the reinforcement for subsea. This composite wrap is designed to reinforce damaged or deteriorated pipes, providing structural integrity and preventing further leaks or failures. By using the wrapping machine, divers can precisely apply the composite wrap, ensuring a uniform and strong bond between the pipe and the wrap. The BobbyWrap offers several advantages over traditional repair methods. Firstly, it eliminates the need for extensive pipe excavation or removal, significantly reducing the time and cost associated with repairs. Additionally, the machine enables repairs to be carried out underwater, eliminating the need for costly and time-consuming dry docking operations. The wrapping machine is designed to be user-friendly and efficient. Its compact and lightweight design allows for easy transport and maneuverability in challenging underwater conditions. The machine is equipped with advanced controls and sensors, ensuring precise application of the composite wrap while providing real-time monitoring of critical parameters such as tension and overlap. The collaboration between Total and 3X Engineering in developing the Bobarap demonstrates their commitment to advancing the field of subsea pipe repair and maintenance. Steel repairs are an essential aspect of ship maintenance and repair processes. When it comes to the MV Mariner, MEC Shipyards has effectively addressed the steel-related issues that arose during its time in canal waters. One of the specific steel repair tasks carried out by MEC Shipyards was the cropping and renewal of the Tramson plate section. The Tramson plate is a structural component that provides stability and strength to the vessel's framework. Over time, due to wear and tear or other factors, certain areas of the Tramson plate may become damaged or weakened. In such cases, it is necessary to crop out the affected section and replace it with a new, robust piece of steel. MEC Shipyard successfully completed this process, ensuring the integrity and safety of the MV Mariner. In addition to the Tramson plate, MEC Shipyards also address the side shell plating of the vessel. The shell plating forms the outer skin of the ship, protecting the internal structure from external elements and providing buoyancy. Similar to the Tramson plate, sections of the side shell plating can experience damage or corrosion, compromising the vessel's overall performance and safety. To rectify this, MEC Shipyards cropped out the affected areas and replaced them with new, durable sections of steel. By undertaking this repair, they effectively restored the structural integrity and longevity of the MV Mariner. MEC Shipyards takes pride in offering a comprehensive ship repair solution to its clients. Whether it's routine maintenance repairs or emergency situations arising from collisions or accidents, their team of experts is well equipped to handle the diverse repair needs of vessels. With a focus on delivering quality workmanship and ensuring the safety of the vessels they service, MEC Shipyards has established itself as a reliable and trusted partner in the maritime industry. One notable application of underwater welding is the installation of sacrificial anode holders. These small yet vital components play a significant role in preventing the premature rusting of various metal objects submerged in water. Whether it's steel boats, marine engines, water heaters, bridge piles, or other wet metal structures, sacrificial anodes protect them from corrosion. By utilizing an anode made of metals like zinc, the anode sacrificially decomposes before the steel begins to rust, effectively safeguarding the integrity of the underlying metal. Underwater welding shines as a crucial technique in situations where water cannot be removed from the weld site, eliminating the need to lift heavy objects out of the water and reducing costs. At CSD, our highly skilled professionals regularly employ underwater welding for a wide range of purposes. Hull repairs, for instance, can be efficiently carried out using underwater welding techniques, ensuring the structural integrity of vessels. Anode support welding is another common application, as it aids in maintaining the proper positioning and stability of sacrificial anodes, guaranteeing continued protection against corrosion. Moreover, underwater welding finds its utility in sheet, pile, wall, and shutter repair. These vital structures often face deterioration due to water exposure and require immediate attention. By employing the expertise of underwater welders, repairs can be performed efficiently without the need for costly and time-consuming processes such as lifting items out of the water. Safety is paramount in the field of underwater welding, and our team is equipped with the latest tools, techniques, and knowledge to ensure secure operations. Our professionals undergo rigorous training, honing their skills and staying updated with the best practices in the industry. We prioritize the well-being of our personnel and maintain strict adherence to safety protocols to mitigate risks associated with working in challenging underwater environments. The Komatsu D155W is an impressive underwater bulldozer that has proven its capabilities in various applications, including the restoration of harbors damaged by natural disasters like tsunamis. One notable example of its effectiveness was witnessed in Iwate Prefecture, Japan, where it played a crucial role in the restoration efforts following a devastating tsunami. The D155W is specifically designed to work in aquatic environments, making it ideal for tasks such as harbor restoration. It is equipped with several features that enable it to operate effectively underwater while maintaining its stability and maneuverability. One key feature of the D155W is its sealed and waterproof cabin, which ensures the safety and comfort of the operator in submerged conditions. The cabin is designed to withstand the water pressure and is equipped with advanced controls and instrumentation for efficient operation. This enables the operator to have full control over the machine's movements and functions, ensuring precise and accurate work. The bulldozer is powered by a robust engine that provides the necessary power and torque to operate effectively in underwater conditions. The engine is designed to withstand water exposure and is equipped with special filters and seals to prevent water ingress, ensuring reliable performance even in challenging environments. To enhance its underwater performance, the D155W features a specially designed chassis and tracks. The chassis is reinforced and sealed to prevent water penetration, and the tracks are designed to provide excellent traction and stability on various underwater surfaces, including sand, mud, and debris. The D155W is also equipped with a powerful hydraulic system that enables it to perform a wide range of tasks underwater. It features hydraulic arms and attachments, such as buckets and rippers, which can be used for excavation, dredging, and debris removal. The hydraulic system provides precise control over these attachments, allowing the operator to perform intricate and detailed work even in challenging underwater conditions. In the case of the harbor restoration in Iwate Prefecture, the D155W played a vital role in clearing debris, removing sediment, and reshaping the harbor floor. It operated in tandem with other construction equipment and teams, working tirelessly to restore the harbor to its pre-tsunami condition. The D155W's underwater capabilities, combined with its robust construction and powerful performance, make it an invaluable asset in post-disaster restoration projects. Its ability to operate effectively in submerged conditions allows for efficient and timely restoration of harbors, minimizing downtime and enabling affected communities to recover and rebuild. The construction of a Viking Dragon ship is an intricate and labor-intensive process, requiring skilled boat builders and adherence to traditional techniques. The boat builders on a small island outside of Haugesund, Norway, are recreating a dragon ship based on the Old Norse sagas. These sagas speak of the magnificent dragon ships used by chieftains and kings during the Viking Age for both attack and defense. Unlike modern construction processes that rely heavily on working drawings, the Vikings built their ships based on practical experience. However, in the present project, modern authorities have introduced working drawings, although these drawings are subject to constant modification throughout the construction process. The construction of the Viking Dragon ship begins with the keel, which is stretched. Templates for the stern and the dragon head are placed, and an angle board is used to control the angle of the gar board. The shipbuilders meticulously work on the lot, which is the curved transition between the straight keel and the stem and stern. Various shipbuilders are assigned different tasks. Olaf planes the upper section of the stern, while Natalia works on the curved hood end boards that will be part of the ship's bow. Gunner marks off the support blocks for the bottom, and clinker construction is employed, which means the frames are not installed at the outset. Instead, each board is adjusted to achieve the desired tough and flexible shape of the hull. Frames are then added at critical points to balance the ship's overall structure. One notable aspect is the curved hood end boards closest to the stem and stern, as their shape significantly influences the ship's seagoing qualities. To ensure watertightness, the shipbuilders apply tar as a sealant in the joints between sections, placing hemp in the tar joints. This practice is followed in all joints and between overlapping boards in the strikes. The construction progresses as the stern sections are carefully guided and joined to the keel. Large clamps and iron rivets are used to secure the sections together. The shipbuilders work on planking, cutting nails, and clinking them in place. Approximately 100 hammer strokes are required for each nail, a process that has given rise to the name clinker-built ships. Wood clamps are utilized to force the overlapping boards together before clinking, ensuring a tight fit. Holes are drilled for the iron nails, which are then hammered into place from the outside of the hull. The shipbuilders use a dolly to force the rove down the nail from the inside. This process is repeated for each board in the bottom of the ship. As the construction progresses, the shipbuilders work on the ribs and lower bands. The ribs are attached with wooden nails, and precise customization is crucial to maintain the desired shape of the hull. Attention is paid to smooth contact surfaces between the ribs, support blocks, and strikes to evenly distribute forces on the hull. The shipbuilders continue their work, adding more strikes and ribs. The special hood and boards in the bow require meticulous measuring and tweaking to ensure the ship's seaworthiness. Other components, such as standing knees, stringers, and cross braces, are shaped, fitted, and mounted to strengthen the hull and distribute forces. Wood carvers join the construction process to craft the dragon's tail and head. Selecting suitable wood, they meticulously work on the templates and carve the various parts that will make up the dragon's head. After over 20 months of unwavering commitment and meticulous craftsmanship, the Viking Dragon Ship named Harald Fairhair is approaching its final stages of construction. The dedicated team of 10 skilled boat builders has poured their expertise and passion into every detail of the ship. Harald Fairhair spans an impressive length of 35 meters and boasts a width of approximately 7.5 meters, making it a formidable vessel on the open seas. To power this magnificent ship, a crew of 100 men will be required to row with synchronized strength and endurance. With the anticipated launch date set for June 2012, the completion of the Viking Dragon Ship will be a remarkable accomplishment, representing the culmination of ancient shipbuilding techniques and the revival of a rich maritime heritage.
The wind farm is located offshore and comprises 87 wind turbines with a collective capacity of an impressive 660 megawatts. This project showcases the latest advancements in wind energy production, requiring larger and sturdier foundations to accommodate the new generation of wind turbines with 7 to 8 megawatts capacity each. One of the key challenges in constructing the Walney extension wind farm was the transportation of the massive monopiles and transition pieces from their European suppliers to a stockyard in Belfast. Van Odd efficiently managed this logistical feat, ensuring the components were delivered safely and on schedule. The scale and weight of these components demanded innovative manufacturing and installation techniques, pushing the boundaries of what was previously achieved in offshore wind farm construction. To execute the foundation installation, Van Oord employed specialized vessels with cutting-edge technology. The company's 8,000-ton heavy lift installation vessel, the Spawn, was specifically designed for the task. Equipped with the latest innovations, the vessel efficiently installed 56 monopiles using its redesigned massive Griffin system. This impressive feat highlighted Van Oord's commitment to using advanced equipment to overcome construction challenges and deliver high-quality results. For the transportation and installation of the transition pieces, Van Oord relied on its in-house designed offshore installation vessel, the Aeolus. Tailored for the specific demands of the project, the Aeolus demonstrated its capability by handling 5 sizable transition pieces per voyage. The team benefited from recent improvements in dynamic positioning accuracy, ensuring the vessel maintained an exact position in the water within 15 centimeters. This precise positioning was crucial during the delicate installation process, avoiding damage to the crane caused by the ship's wave movements. One notable aspect of the construction process was the implementation of a special shock absorber to enhance safety and prevent potential damage to the equipment during the floating works. This further showcased Van Oord's dedication to maintaining the highest safety standards while executing complex tasks. With the successful completion of the foundation installation, the Walney Extension offshore wind farm was ready to receive its wind turbine generators. These turbines, boasting 7 to 8 megawatts of capacity each, represent the newest generation of wind energy production, promising higher efficiency and greater energy output. The construction of the Walney Extension offshore wind farm was a testament to Van Oord's expertise in the field, as well as the dedicated efforts of its employees and partners. By overcoming logistical challenges, utilizing specialized equipment, and implementing the latest innovations, Van Oord contributed significantly to making wind energy more competitive and accessible for future generations. Caissons are concrete and steel structures that provide rigidity and stability to various marine elements, not limited to vertical quays or docks. They can be utilized in sea containers, offshore foundations, mooring dolphins, and offshore stations. This flexibility allows for a mixed solution, involving the simultaneous construction of a dock and quay, instead of opting for a breakwater approach. The largest caisson built using Aviona's proprietary technology is the biggest reinforced concrete caisson in the world, measuring an impressive 66.5 meters in length, 24.6 meters in width, and 34 meters in height. The construction process begins with the introduction of a raft with steel rods to reinforce the caisson's floor. After pouring and setting the concrete, the formwork is lowered and coupled up as it slides down, and the concrete is poured. Once the caisson is complete, it is submerged in the water by removing the formwork, leaving it ready for launch. Bedding layers for the caissons are constructed using barges, and the caissons are anchored and supported in place by ballasting themselves, making them stable for building the superstructure of future quays or docks. One of the main advantages of Caisson technology is the significant reduction in construction time. Up to 200 meters of dock can be built per month, and this approach is much safer for workers compared to traditional methods, as construction occurs on the floating dock itself, ensuring easier implementation and supervision of safety measures. From an environmental perspective, Caisson technology offers several benefits. It reduces the consumption of natural resources and minimizes heavy vehicle traffic, resulting in lower CO2 emissions and noise levels. Moreover, it eliminates on-site congestion and potential traffic accidents, contributing to a more sustainable construction process. Another logistical advantage is the possibility of manufacturing caissons at a different location and then joining them at their final position. This allows for easier transportation and reduces the impact on the environment and on site space. Aviana Infrastructure DOS possesses 3 Caisson-building floating docks, enabling them to undertake marine structure projects worldwide. The Balea, the smallest of the 3, is a versatile and transportable solution capable of producing caissons measuring 26 meters in length, 17 meters in width, and 18 meters in height. The Kujida holds the world record for constructing the largest reinforced concrete caisson, capable of manufacturing caissons measuring 67 meters in length, 32 meters in width, and 34 meters in height. The latest addition is the Kuga 2, equipped with cutting-edge technology and capable of producing caissons measuring 57 meters in length, 26 meters in width, and 30 meters in height. Aviana's expertise, combined with their advanced technology, positions them as an ideal company to efficiently and safely undertake any marine structure project while maintaining a strong commitment to environmental conservation. The construction of the Quay Wall at the new Tema port facility involves the innovative use of caissons, which are massive concrete structures designed to create a solid foundation for the quay. The process begins with dredging a trench in the seabed, reaching a depth of 19 meters to accommodate the 74 caissons. The construction of each caisson takes place on land, where 1,000 cubic meters of concrete are used to form each unit. These immense concrete structures weigh a staggering 2,600 tons each. Once completed, the caissons are carefully transferred onto a floating dock using a specialized technique. They are rolled onto the dock with the aid of inflatable airbags, making the process more manageable and efficient. With the caissons now on the floating dock, the next step is to position them near the designated location for the quay wall. Once in position, the floating dock is deliberately sunk, causing the caissons to float independently. This floating ability of the caissons allows them to be easily moved into their required positions by tugboats. Once the caissons are in their designated locations, they are intentionally filled with water. This controlled flooding causes the caissons to descend gradually and settle firmly onto the seabed. By filling the caissons with sand, additional stability and anchoring are provided, further securing their position. The final stage of the quay wall construction involves casting the deck of the quay on top of the caissons. This deck acts as the platform for the port facility, enabling it to accommodate cargo handling, docking of ships, and various other port activities.